Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 1 paper from autumn 2023. This paper is worth 120 marks in total, and this is the third video of 6. It will focus on questions 13 to 16, which account for 22 of these marks. Eduqas Component 1 papers are non-calculator papers, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 13. Show that the lines 3y subtract 12x equals 9 and 2y equals 8x subtract 13 are parallel to each other. Okay, so for lines to be parallel, we need the same gradient. Okay, and to be able to compare the gradients, it's easier to write these equations in the form y equals mx plus c, because m is our gradient. So if we write them in that form, we can compare them and show that they're parallel, because hopefully it'll be the same. So let's start with this equation. We have 3y subtract 12x equals 9. Now I want it to be y equals mx plus c. So the first thing I'm going to do is I'm going to add 12x, guys. So that would leave me with 3x equals 12x plus 9. And then I'm going to divide by 3. So y equals 12 divided by 3 is 4. 4x plus 3. So the gradient of this line is 4. We now need to do the same with the other equation so we can compare the gradients. So fortunately, y is already isolated on this one. So the only step we're going to have is to divide by 2. So y equals 4x subtract 13 over 2. I'm going to leave that as a fraction as 13 over 2 because that's not the part of the equation of the line I'm interested. I'm interested in the coefficient of the x because that tells me their gradients. So I'm going to write a statement here now. Same gradient, so parallel, just to finish it off. Part B. The diagram shows the curve y equals 5 subtract 4x subtract x squared. So we've got this parabola, this quadratic curve here. Calculate the coordinates of the turning point of the curve. So the turning point of the curve is the coordinate at which the line of symmetry of this shape would intersect the curve. So up here, this is the turning point. So we're looking for the coordinate of it. Now the line of symmetry is exactly down the middle for a quadratic, guys. Okay, so this point here on the x-axis is exactly in the middle between -5 and 1. So -5 to 1 is 6 places. So there are 3 places either side. So -5 plus 3. So this must be -2. So x is -2. So the x coordinate is -2. And I can now use that by substituting into this equation. So y equals 5 minus 4 times -2, because x is -2, minus -2 squared, because we want the corresponding y coordinate. So we have 5 subtract 4 multiplied by -2 is -8, -2 squared is +4. Notice my use of brackets here because I don't want to mess up with any of these double signs. So y equals 5 subtract -8, so that's 5 plus 8 subtract 4. 5 plus 8 is 13, take away 4 is 9. So the y coordinate is 9. Question 14a. Find the next term in this sequence. So I need to find what's happened to go from one term to the next. So I'm going to start with the second term and I'm going to divide it by the first term. Okay, so I'm dividing fractions, so I'm going to keep the first fraction the same. I'm going to write the reciprocal of the second fraction and multiply. So this gives me -50 over 20. Okay, so now I'm going to multiply the fourth term by this, and then that will tell me what the fifth term is. So -625 over 16 multiplied by minus 50 over 20. Well, a negative times a negative gives me a positive. 16 times 20 is 320. 625 times 50. So 0, 0, 0. 5 times 5 is 25. 5 times 2, add that is 12. 5 times 31. So 31250. So 31250. But I'm going to now just simplify that a little bit. So I'm going to go 3125 over 32. So 3125 over 32, because you can see 2, 4, 8, 16, 32. The denominator is getting doubled each time. So I wanted to make sure that I had a denominator of 32. Part 2, find the next term of this Fibonacci style sequence. So a Fibonacci sequence is generated by adding the previous two terms. So 10 plus 15 is 25, 15 plus 25 is 40, 25 plus 40 is 65, 40 plus 65 is 105. So that's our next term. Part B, the nth term of a sequence is 10 root 5 all to the power of n. Calculate the fourth term of this sequence. You must simplify your answer. So n is the term number. So we are calculating 10 root 5 to the power of 4. Okay, so that would be 10 root 5 multiplied by 10 root 5 multiplied by 10 root 5 multiplied by 10 root 5. 10 times 10 times 10 times 10. And then root 5 times root 5 would be 5. Root times root 5 would be 5. Times that by 25. So that would be 25. Oh no, it would be 250,000. So the fourth term is 250,000. Part C. Find the nth term of the sequence below. So the first thing we need to do is find the difference. So from 3 to 15 we add 12. Add 20, add 28, and then add 36. So the first difference isn't the same. So this is not a linear sequence. This is a quadratic sequence. So we need to find the second difference. So and that's the difference of the differences, don't forget. So from 12 to 20 we add 8, 20 to 28 we add 8, 28 to 36 we add 8. So the second difference is 8. We halve that second difference to find our n squared part of our nth term. So we're going to have 4n squared. And what I'm going to start by doing is generating the 4n squared sequence. Okay, you know I like a table. Okay, so 4n squared, first term, second term, third term, fourth term, fifth term. I'm only doing 5 because I've got 5 terms there to compare them with. So when n is 1, 1 squared is 1, multiplied by 4 is 4. When n is 2, 2 squared is 4, multiplied by 4 is 16. When n is 3, 3 squared is 9, multiplied by 4 is 36. When n is 4, 4 squared is 16, multiplied by 4 is 64. When n is 5, 5 squared is 25, multiplied by 4 is 100. So now what I'm going to do is I'm going to write this sequence underneath. So we've got 3, 15, 35, 63 and 99. I've not left myself a lot of space here, guys, so I am going to move to the bottom. I do apologise for that. So what I'm going to do next is I'm going to see the difference, okay? So what I need to do to get from 4n squared to this sequence that we're starting with. So to get from 4 to 3, I need to take away 1. From 16 to 15, I need to take away 1. From 36 to 35, take away 1. 64 to 63, take away 1. 100 to 99, take away 1. So I'm taking away 1 every time. So the nth term of this sequence is 4n squared subtract n. I don't need to do anything else from this point. So 4n squared subtract n. And you can check this, because if n is 1, to generate this first term, 1 squared is 1, 4 multiplied by 1 is 4, but then subtract 1 is 3. So we know that that's the correct nth term. Question 15. Factorise 5x squared, add 13x, add 6. So this is a quadratic and I've got a squared term and a constant number, so I'm definitely going to need 2 brackets for this. However, we have a coefficient in front of the x squared. Now this coefficient is a prime number, so the only 2 options I have to write in this bracket are 5x and x. There's only 5x multiplied by x that would give me 5x squared. So that gives me a starting point. So now we're still looking for 2 numbers that multiply to give us 6 to go in here. So we have 1 and 6, 2 and 3. However, we need those numbers to add to 13. Now looking at that, neither of those pairs of numbers is going to add to 13. But what we need to remember is that whichever number gets put here, when we expand those brackets, if we were to, gets multiplied by 5. Okay? So we're aiming for 13. Whatever goes here gets multiplied by 5. So let's think about this. If I multiply 6 by 5, that's 30. 30 plus 1 is not 13. If I multiply 1 by 5, that's 5. 5 plus 6 is 11, not 13. So this is not the pair that we're looking for. This is the pair that we're looking for, but which way round do we put them? Okay, well 2 multiplied by 5 is 10, and then if we add 3, that gives us 13. So we want the 2 to be in the opposite bracket to the 5x, and we want the 3 to be inside the other bracket. Part B. Adrian is trying to solve 3 subtract 4x is greater than 11. He writes the following. Adrian's method is incorrect. Explain why. Okay, so let's have a look at what he's done, or let's do it next to it, what we would do. So the first thing I would do here is I would subtract the 3. So I have negative 4x is greater than 11 subtract 3, which is 8. The next step would be to divide by negative 4. So I'm going to divide by negative 4, but when I divide by a negative, it changes the inequality sign. So that would become less than, and then 8 divided by negative 4 is negative 2. So he's incorrect because he didn't change the sign when he divided by a negative. So we can say that Adrian didn't change the sign when he divided by a negative. Okay, part C, simplify. So we've got x to the power of 4 all to the power of 3 divided by x to the power of 2. So we're going to evaluate that numerator to start off with. So this is a power of a power rule with the bracket. So it's x to the power of 4 multiplied by 3, which is x to the power of 12. We're still dividing by x to the power of 2. Our laws of indices for division, if we're dividing and the base number is the same, we can simply subtract the power. So it's x to the power of 12 subtract 2, which is x to the power of 10. 16a. The vector t equals 7, negative 2, and the vector w equals negative 2, 4. On the grid below, draw the vector t, add w. So let's find the column vector t, add w to start off with. So t add w is equal to t plus w. So 7 plus minus 2 is 7 minus 2. So that becomes 5. Minus 2 plus 4 becomes 2. So the column vector for t add w is 5, 2. Okay. This vector gives us a direction, don't forget. So we'll have a starting point, and then the vector is going 5 places to the right and 2 places up. So let's start here. We're going to go 5 right and 2 up, and then we're going to draw a line, and then we're going to draw an arrow in the direction that we travel, because we started here and we went there. So this is t plus w. Part B. We've got a diagram with vectors involved there. The diagram's not drawn to scale, so we can't measure anything directly from it. W, Y, Z is a straight line. So this is a straight line. The vectors wx and yx are shown in the diagram. So wx is 6a, yx is 4b. Given that yw to yz is 2 to 3, so yw to yz is 2 to 3, write the vector wz in the form ma plus nb. So we're aiming for the vector w to z, but the thing we don't know is anything at all about that. So we're going to start by getting this vector wy. Okay, so wy, so to go from w to y, we're going to follow journeys that are labelled with vector notations a and b so that we can represent it in some way. So we would go to wx and then xy, so that's plus xy. Well, wx is 6a, and it stays as 6a because we're travelling in the same direction as the arrow. Xy is travelling in the opposite direction of this arrow, so it would be the inverse sign. So it's not positive 4b, it would be negative 4b. So wy is 6a subtract 4b. Okay, now they gave us a ratio here. They said that wy to y to z is 2 to 3. So wy y to z, because we need to know y to z, so we've got the complete vector here. So this is in the ratio 2 to 3. So this ratio of 2 here is the vector 6a minus 4b. Okay, so if I divide this by 2, I get 3a minus 2b. So that tells me what one part of this ratio is equal to. Now, wz has 5 parts in total, so I'm going to multiply this by 5. So when I multiply it by 5, wz becomes 15a minus 10b. And it's in the form ma plus nb. M is 15, n is 10.